Hello girls, this is Module 2 of Technology Exploration, revision for the exam, Term 1. In Module 2, you should know the following. Define force, what is force, how is it applied, what are the different types of forces, what is motion, what are the different types of motions, find mechanical advantage and calculate efficiency. You should be able to identify the 6 simple machines. You should be able to identify any simple machine within a compound machine. And you should be able to find the gear ratio. You should be able to identify simple and compound gear trains, etc. So let's have a look at this module. What is a simple machine? A machine that makes your life easier is a simple machine. What is motion? An object is under motion when it is moving and continuously changing its position. Let's see, can I highlight here? Yes. Alright, then you should know the different types of motions. If the motion is in a straight line, it's called a linear motion. If it is around a pivot, if it's moving in circles, it's called circular. And if it's swinging side to side, it's oscillatory. And if it's moving back and forth, it's reciprocal. Examples will be linear motion, a moving car, a shooting arrow, a bullet, anything that moves in a straight line. Rotatory motion, anything that moves in a circular direction, you can say. A fan, a clock, the hands of a clock, they move that's a circular motion too. Reciprocating movement, a weightlifter, up and down, or a saw to cut wood that goes side to side, so that is reciprocating too. Oscillatory could be a swing or the pendulum of a clock, that's oscillatory, anything that swings. What is force? A force is a push or a pull to change the motion of an object. Okay, then you should also know long range force, gravity and magnetism, and you should also know contact forces. What are contact forces? Contact force when you touch something to move its position. You should know the unit of force, it's Newton. Okay. Next comes effort, load and resistance. Now these three things will be used when we are talking about simple machines. So effort force is the effort that you put, the input force that a person or a motor will put. That is called an effort force. Yeah. Okay. The load is what you're trying to move. Now, yes, the load is what you're trying to move, and resistance is also what you're trying to move. Load and resistance. Okay, what is mechanical advantage? Let me highlight this first. So what is load or resistance? The output. And what was effort force? That was the input. So what is mechanical advantage? It is the advantage that you get when you use a machine. And how can you define it? It's the ratio between output force and input force. Now for these formulas, remember what I told you in class. Don't memorize the formulas. You should memorize the triangles that I've given you. That will make it much easier. I will make a video later today explaining how to solve a question. So hopefully you'll remember the triangles from there. So in this chapter, you should be able to calculate the ideal mechanical advantage, the actual mechanical advantage, efficiency, load force, effort force, actual effort force, and so on. Now please remember, actual mechanical advantage and ideal mechanical advantage and efficiency, they do not have units. So don't make the mistake of writing a unit for the answer, because that will get you to lose marks. Forces, on the other hand, you must write the unit. The unit of force is Newton. The unit of any length will be meters or centimeters, as the question says. What is the difference between ideal mechanical advantage and actual mechanical advantage? Ideal mechanical advantage is when there are no forces being considered. Now, ideal circumstances don't exist. Where do we lose energy? There is friction, there is air. So because of these losses, we never get an ideal mechanical advantage. Instead, we get what is called an actual mechanical advantage. Actual mechanical advantage will always be lower than the ideal mechanical advantage. The ratio actual mechanical advantage divided by ideal mechanical advantage is called efficiency. Yeah, usually efficiency will be given in percentage. So if they give you 85% for your calculations, you will convert it to 0.85. Okay, moving on. You should know the 6 simple machines: lever, wedge, pulley, wheel and axle, screw, and inclined plane. The calculations that we can ask you will be based on levers and pulleys. Wedge, wheel and axle, screw, and inclined plane you will learn later on. So in a lever, what do you have? You have a fulcrum, also called the pivot. One side is the load, the other side is the effort. Yeah. The distance between the fulcrum and the load is called the load length, LL, or load arm length. The distance between the fulcrum and the effort is called effort arm length or effort length. Okay. You should also know the 3 different types of levers. Now, the easiest way to remember and to figure out which class it is to remember what goes in the middle. So in first class levers, what is in the middle? The pivot or the fulcrum. In second class levers, load will be in the middle, and in third class levers, effort will be in the middle. So also remember, third class levers will be the least efficient. Efficiency of third class will be between 0 and 1. Why is this so? Because effort is in the middle. So we need more effort to move the load. You should also Google and find out some examples of the 3 classes of levers, because it's a very common question and it might be asked. They might show you a picture and they'll ask you what type of lever it is. So you should be able to identify. The best way to do is to use this approach. Label them. Effort is in the middle, fulcrum, load, and then whatever's in the middle will give you a hint as to which class it is. Then, of course, our favorite word problems, our best friends, they will definitely ask you a word problem. My suggestion to you is, when you are solving a problem like this, for each part, draw a triangle and write the formula. Very, very important. Because if, let's say, your calculation is not correct, you will get part marks for the formula. Also, do not forget to write the unit. The unit is very important. If it's force, the unit will be Newton. If it's length, the unit will be meters, and so on. If you do not write the unit, you lose marks. So please make sure you do that. Now, once you've memorized the triangles for levers, the same will be used for pulleys. Now, what did we study in pulleys? Pulleys are also, you can also find the mechanical advantages of pulleys. The only difference between a lever and a pulley is that the IMA of a pulley is found by counting how many support cables there are. So, for example, in a fixed pulley, there are three types of pulleys: fixed pulley, movable pulley, and block and tackle. Now, in a fixed pulley, how many support cables do you see? Only one. So the IMA of a fixed pulley is 1. In a movable pulley, how many support cables are there? There is 1 and 2. There are 2 support cables. So the IMA is 2. What does it mean? It means if my load is 100 newtons, I need only 50 newtons. I need half of the effort to move this load. That's what IMA of 2 means. If the IMA was 3, it would mean I need only 1/3 of the effort. Block and tackle. Here in this case, you have 1 and 2. You've got 2 support cables. Why do we not count this as a support cable? Because the direction is pointing down and so is the weight. Both directions are the same. So this is not a support cable. Look at this diagram again. Why is this a support cable? Because the weight points down and this points up. The directions are different. So this is a support cable. Therefore, there are 2 support cables. Okay. So once you know the IMA, you can use the same for the triangles, the formulas as the previous topic, which is levers, and do all your calculations. Again, the same thing. If they ask you for efficiency, you found the answer, convert it to percentage. If you find force, write the unit. If you find a length, write the unit. Mechanical advantage, efficiency will not have any units. Then we come to mechanisms. What is a mechanism? A mechanism transfers the energy from one thing to another. So it's an assembly of moving components. Please remember this. A mechanism is an assembly of moving mechanical components like gears, bearing, linkages, etc. Now, what is a gear? A gear is a toothed wheel that transmits rotary motion and torque. What is torque? Torque is a force that causes an object to rotate. Now, if you have 2 or more gears, one of them will be the driver gear, the one that is turned by an outside force, also the input. And then the other one will be the driven. We know this. Now, what can we use a gear for? We can use it to change speed, direction, or force. There are 2 types of gears: external spur, internal spur. Externals are connected externally, internals are connected internally. External gears will move in opposite directions and internal spur gears will move in the same direction. You should also know applications of gears. So gears are used in hand drills, in cars, the gearbox used to change the speed, also in clocks. There are two types of gear trains that we have studied. A simple gear train, it has only one gear per shaft, and a compound gear train in which you have two gears of different sizes on the same gear shaft. You should know how to find the gear ratio of both types of trains. For a simple gear train, it's very, very simple. The gear ratio is the number of teeth of the output gear divided by number of teeth of the input gear. You might have 100 gears in between them, but you ignore them. You look at the output, you look at the input, and you divide the two. In the exam, be careful to check which one is the output and which one is the input. Don't mix them up. Right. How to find the gear ratio of a compound gear train. Now, for a compound gear train, you find individual gear ratios. Where is it? Yeah. So, find the gear ratio of each set of gears. So, this pair, 1, 2, then the next two, then the next two. In this, they haven't shown us a compound gear train. Let's look at this diagram. So find the gear ratio of A and B1. B1 over A times C1 over B2 times output over C2. So you find the ratio of each pair of gears and then multiply them. This will give you the gear ratio of a compound gear train. One more thing. What is an idler gear? A gear that's stuck to the middle of two gears is called an idler gear. What is the job of it? It adds spacing and it makes them rotate in the same direction. If this gear was not here, then both would move anti-clockwise. This would move anti-clockwise and this would be opposite. So this would become clockwise. But because of the idler gear, now both are moving anti-clockwise. So that is it in Module 2. Good luck.